Alright, so we're going to graph a system of linear equations to find out where they intersect, which is a method of finding out the solution to the system of linear equations. The point at which they intersect is the solution. And a lot of times, the best way to find the solution is to graph the two lines and just visually see where they intersect. That's kind of the purpose of a coordinate plane, just to visualize things that are hard to visualize otherwise, and to make things easier and more intuitive for us. So I'll take you through the process of looking at this system of linear equations. I've got two linear equations, and this is a system of linear equations, meaning the x and y mean the same thing, and we're dealing with these equations at the same time, so that we can plot them both on the same coordinate plane and see where they intersect. So you can do this in different ways. There's different ways of graphing linear equations. So for me, these are already in slope-intercept form. So that's y equals mx plus b. Y equals something times x plus something. So that's the slope of the line, and that's the y-intercept where it crosses the y-axis. So, if you're comfortable with graphing using your knowledge of the slope-intercept form, do that. I'll show you with a method that will work for an equation in a lot of different forms, which is just to make a table. You just need 2 points. So that's going to be a table for our first equation. So let's call this number 1. Call this number 2. Number 2. Okay, so just pick a couple points. All you really need is 2 points in order to graph a line. So 0 and let's say 3. You just pick any x values you want, plug them in, and see what you get for y. I like picking 0 because it's pretty simple to solve. So let's find out what we get for y. So I'll just write out the first one, and then I might just say the second one. So so y equals 2. Okay, now we're plugging in 0 for x. So we've got 2x. So instead of x, we're going to put a 0 plus 3. So y equals 2x plus 3. Well, I'm putting in a 0 for x and seeing what happens. 2 times 0 is 0, plus 3 is 3. So y equals 3. So when x is 0, y is 3. I'll go ahead and write out the second one. We're going to plug in 3 for x, see what happens. Y equals 2x plus 3. Instead of x, we're putting in a 3. So 2 times 3 is 6, plus 3 is 9. So when x is 3, y is 9. Alright, we're going to do the same thing for the other equation. Let's say, I'm going to say let's 0, just for fun, let's do a negative 2. I don't know why, just because. Okay, so what happens when we plug in a 0 for x? So y equals negative 3 to x minus 2. So x is 0. So negative 3 times 0 is 0. 0 minus 2 is negative 2. So y is negative 2. So when x is 0 for this line, y is negative 2. Okay, what about when x is negative 2? Y equals negative 3 times x. In this case, x is going to be negative 2. Okay, negative 3 times negative 2 is positive 6. So 6 minus 2 is 4. So when x is negative 2 on this line, y is 4. So that's all we need. 2 coordinate pairs each, because we can just connect the points, and then we're done. So let's start with this first equation, number 1. So our first point is 0, 3. So x is 0 and y is 3. 1, 2, 3. That's our first point. And our second point is 3, 9. So x is 3, 1, 2, 3, and y is 9. 1, 2, 3, 4, 5, 6, 7, 8. 9 up there. let's say. Okay, and so we just connect those two lines. Try to do the best. Let's see, maybe. Oops. Now let me adjust this. You know, when you're doing it on your paper, just use a ruler or something. Just get it as close as you can. All right, something like that. It's not perfect, but something like that. Connecting two lines or 2 points. All right, let's check it. Check the second guy. So our first coordinate pair is 0, -2. So when x is 0, y is 1, 2, -2. All right, then when x is -2, y is 4. So 1, 2, -2. Then +4. 1, 2, 3, 4. All right, I'm just gonna adjust that point. You know, something like that. Now I'm gonna connect the two. Looks pretty close. Kind of going off my graph here. Try to keep your lines on the graph. I'm gonna do that. Looks fancy. Okay. So what was the question? The question was, where do they intersect? So let's just look. I mean, it looks like right there at the point -1, +1. So let me just. So they looks like they intersect at -1, and then y is +1. Okay. Just for fun, I'm gonna put the intersection explosion right at that point. So that's the intersection point. Boom. All right. So make a little table for each linear function that you're trying to graph. Use that table to create a couple of coordinate pairs. Plot those coordinate pairs onto your coordinate plane. Connect those points with a straight line, and then see where those straight lines cross. And that's the intersection point. All right.